give it to you hot like a sauna. Well, I'm on the way, the time cold. I wanna be keeping you warm. I got the right temperature.
Now what we have to do quite a bit is convert between Fahrenheit and Celsius and Kelvin. And that's because almost all countries, except for the United States and about 5 smallish countries, use the Celsius scale, whereas we use the Fahrenheit scale. We're holdouts. So if we go to another country, this is an immediate need to convert between Celsius, which almost all other countries are using, and Fahrenheit. Also in science and engineering, we use the Celsius scale, and that's because it's more convenient having 100 divisions or degrees between these two set points, or between these reference points of the freezing water and the boiling water, whereas it's a little bit more difficult to work with Fahrenheit. I show in this graphic the Fahrenheit scale going from 32 degrees for the freezing water to 212 for the boiling water, whereas in Celsius we go from 0 degrees for the freezing water to 100 degrees for the boiling water. That is, there are 180 steps for this same range on the Fahrenheit scale compared to 100 steps for the same range on the Celsius scale. So the Fahrenheit steps must be smaller than the centigrade step. This is like having two people walk the course of a football field, for example. So they're walking the same distance. One person takes 100 steps, whereas the other person takes 180 steps. So that means the person taking 180 steps has to take smaller steps because you take more of them to cross the same distance. Okay, also you'll notice that there is an offset that I show that is 0 on the Celsius scale. It corresponds to the freezing of water, whereas on the Fahrenheit scale it's 32. Now an equation that relates these two is shown, and let me show you the components of the equation so it won't be frightening. The equation used to convert between Celsius and Fahrenheit is Fahrenheit. A value in Fahrenheit is equal to 32 degrees plus the ratio of 180 divided by 100 times the numerical value of the Celsius or centigrade temperature. Now the ratio of 180 to 100 in this conversion equation is attributed to the size of these steps. 180 steps on the Fahrenheit scale, 100 steps on the Celsius scale. So that's where that ratio of 180 to 100 comes in. And then the 32 degrees that we have in the equation is due to this offset between the two scales. Now you'll often see this equation written in the following way. That is, the numerical value of the temperature in Fahrenheit is equal to 32 degrees plus 9/5 times the numerical value of the temperature in Celsius or centigrade. And that, of course, is because 9/5 is just equal to 180 divided by 100. It's the same number. And in a previous slide, I actually had 9/5 written out as 1.8. Well, these are all the same value, so you can write it in different ways. Now, this equation is the one that is probably most useful for you in converting between Fahrenheit and Celsius. And that's because our most common experience is that we are given a temperature in Celsius and we have to, in our minds, or on a piece of paper, or on our iPhone, we have to convert it to Fahrenheit. So let's say that we're going to Europe for the summer, or we're going to watch the next World Cup, and we're going to another country. And we wake up that morning and we're told that the forecast for today is that the temperature is going to be 25 degrees Celsius. So we have to determine, does that mean I need to wear a coat, or can I wear shirt sleeves? What's that temperature correspond in Fahrenheit, which I'm most used to? Well, let's work this problem. So if the forecast for the day is 25 degrees Celsius, how do we handle this? We plug it into this equation. So the temperature in Fahrenheit will be 32 degrees, that offset, plus 9/5 times 25 degrees, 25 degrees being the temperature in Celsius. When we multiply this out, multiply 9/5 times 25, and then add it to 32, we get the number of 77. So that tells us it's going to be a comfortable day. It's going to be nice. We may also have to go the other way around and convert Fahrenheit to Celsius. To do that, the following equation applies. Now you can just do a little algebra and you can go from the equation on the previous slide to this one. It's not that difficult, and you can see the same components, but now they're changed. That is, instead of adding the offset of 32 degrees, we have to subtract that offset. And instead of multiplying by 180 divided by 100, we flip that, and it's by a factor of 100 divided by 180. And the more familiar way in which we see this equation is shown to the right, where we convert the 100 divided by 180 to 5/9. And as an example, let's say that we are spending the summer again in Europe or Canada, but we've brought our cooking books with us, and we want to bake a cake or cook something. But all the ovens in Europe or Canada have Celsius or centigrade scales. So we know that we want to achieve a temperature of 400 degrees Fahrenheit, okay, to bake our cake. So how do we convert that to Celsius? Well, we just plug it into the equation above. So the temperature in Celsius that we need to set our oven to is going to be the temperature in Fahrenheit that we want to achieve, 400 minus 32 degrees, times the factor 5/9. And when we do the math, it tells us that we will need to set that oven to 204.4 degrees in order to achieve a temperature of 400 degrees Fahrenheit. Okay, so we've talked about how we measure temperature, but what is temperature? I mean, other than, what we talk to each other about all the time, what does it actually mean? As I said in the first slide, temperature is a measure of the intensity of thermal energy in a substance. Now, in the chapter on heat and the second law of thermodynamics, we're going to talk about the concept of how thermal energy flows from a hotter object to a colder object, and how that is a very fundamental phenomena in science. Essentially, what I just said is that thermal energy flows from a place where it's more intense, higher temperature, to where it is less intense, that is, lower in temperature. Now, for a long time, scientists attempted to understand this in terms of the flow of something called caloric, which they visualized as a fluid. But now we know that what temperature really is a measure of the kinetic motion of molecules. Temperature is directly proportional to the average kinetic energy of molecules or particles due to random motion. And the little graphic shows a representation of red and blue molecules in random motion. And now you're going to see this visualization as it changes from a higher temperature, and as the temperature decreases, you will be able to see that the motion of the molecules decreases as we decrease temperature. So the molecules start off zipping around very rapidly at high temperature, and as temperature is lowered, the molecules move less rapidly, they slow down, and in this simulation, the lowest temperature, they slow down even more. And if we were to continue to lower temperature to absolute zero, the motion would cease completely. Temperature and kinetic energy. Okay, that simulation attempted to show how temperature is a measure of kinetic energy, and as we lower temperature, we decrease kinetic motion of molecules, and how that is actually the basis for temperature. Now, let's go back, before leaving, let's go back to our thermometer that we saw outside of our window, and it looks like a cold January morning, and we don't know if we need to get out of bed or not. And we noticed that the thermometer said minus 17 degrees. Whoa, that's cold. It's never been that cold where I live. Well, before you get too excited, notice that this thermometer is a Celsius thermometer. Did you notice that? That big C on top? It's a Celsius thermometer. So actually it says minus 17 degrees Celsius and not Fahrenheit. So we've got to convert between Celsius and Fahrenheit to know if it's really, really extremely dangerously cold or not. Or maybe it's sunny. Maybe it's warm. All right, so again, this is the equation we use to convert Celsius to Fahrenheit. The temperature in Fahrenheit, which we want to know if we're familiar with that, is equal to 32 degrees plus the ratio of 9/5 times the temperature in Celsius. So if we plug in minus 17, multiply by 9/5, and realize we can't lose that negative sign because the temperature in Celsius was minus 17. So 9/5 times minus 17, take that number, which is no doubt going to be a negative number, and add it to 32 degrees, the positive value of 32 degrees, to get the temperature in Fahrenheit. You can pause for a second, do the math, and see what you get, and I'll give you a few options. Okay, did you get it right? Okay, we're going to pause, and you'll be given an opportunity to answer a few more problems like this to see if you've got the concept. Okay? And we'll see you in another lesson.